In this video, I'm going to use the two ideas from the previous video, law of sines and the area of a triangle, to solve some problems. Recall the law of sines says that the ratio of an angle to its opposite side in any triangle is always the same. So we're going to use this idea to set up some problems and set up some equations we can use to find some missing sides. The directions ask us in this question to use the law of sines to solve these triangles. Solve triangle means to find all missing parts, both angles and sides. And then afterwards, we'll also use the area formula to find the area of these triangles. So just like I did with the right triangles, I'm going to make a mini table here to organize myself to make sure I know that I found all the missing parts. So I need to find angle A, angle B, and angle C. I need to find side A, side B, and side C. Things I know three of these things. I know angle C is 85. I know angle B is 34. And I know side C, because that's across from angle C, is 12. Maybe I'll fill in the side across from angle A is little a, side across from angle B is little b. Okay. I need to find the other two missing sides in this missing angle. The angle is easy because I can just use subtraction. And I subtract 180, take away 85, take away 34. I'm left with 61 degrees. So 1 down, 2 to go. I need to find these other missing sides. So in order to do that, I'm going to use this ratio called the law of sines. And that says that I need to take an angle in the side across from it, and that's equal to the sine of a different angle in the side across from it. So I'm going to pick an angle in a side pair that I know, and in the way I've organized my table, it's easy. I just look at find a angle and side that are across from each other that what we know. So in this case, I know that the sine of angle C, which is 85, over the length of side C is 12. This should be equal to the same sort of ratio, but with any other side pair. So it doesn't really matter which side I choose. I'm going to have to do it for both. So maybe I'll do A because it's first in the alphabet. So I know that the sine of angle A, which is 61 degrees, divided by little a, is the same as sine of C over little c. I know 3 of the 4 things in this proportion, so I should be able to cross multiply and get little a by itself. So I'll do that. Cross multiply and get a times whatever the sine of 85 degrees is equal to 12 times whatever the sine of 61 degrees is. I'll get a by itself by dividing by this decimal. And little a is equal to whatever this fraction is. So I'll use my calculator to quickly come up with that. 12 is 12 times the sine times the sine of 61 degrees. I'm in degree mode, so that's good. I don't need the degree symbol. Divided by the sine of 85 degrees. 10.5355. It doesn't tell me what to round to, so by default I'll round to, I guess, 2 decimal places. I should, in the directions of check for understandings or assessments or things like that, it'll be more specific. In this case, 10.5, how about 10.54? I need to find B. One tool I do not have at my disposal is you cannot use the Pythagorean theorem. And the reason you can't is because this is not a right triangle. The Pythagorean theorem only applies to right triangles. If this was a right triangle, then go ahead. But since this is not a right triangle, Pythagorean theorem does not apply. What does apply is the law of sines. So I can play this game again. I'm going to use the sides that I have exact measures for. I don't really want to use the pair of angle A and side A, because I had to round side A. I did not have to round side C. So I'm going to set up a very similar ratio. The sine of angle C, which is 85, over side little c, should be equal to, now I'll use b's. So sine of angle B, which is 34 degrees, over little b. Again, I'll cross multiply and get b times the sine of 85 is equal to 12 times the sine of 34 divided by sine of 85. And now side b is equal to this fraction, 12 times sine 34 over sine 85. So on my calculator, I'm going to make this a little bit quicker. On my calculator, I'm going to highlight the previous entry because it's pretty much the same. I still have a 12 on top. I still have a sine 85 on bottom, but instead of sine 61, I have a sine of 34 to match my two work. Hit enter. You get 6.73595, or maybe to the hundredths place, 6.74. I found all sides and I found all angles. This triangle is solved. We also need to find the area of this triangle. The area, recall from the previous video, the area of a triangle can be written as 1/2 times side times the sine of the included angle. So I just need to pick two sides and the angle that's included in between them to find the area. So I think the area of this triangle should be 1/2. It doesn't really matter how I do. I'm going to use C as one of the two sides because it's exactly 12. I don't have to round it. Maybe I'll pick angle B as the angle I'll include between. So the two sides that are on either side of angle B and the sine of angle B. So sine times A which was 10.54 times the other side, which is 12, times the sine of the angle included between A and C, which is angle B. It's 34 degrees. And this works out to be 0.5 times 10.54 times 12 times the sine of 34 degrees, which works out to be about 35.36 to the hundredths place units squared. Note that this measurement is pretty dependent on how much you round here. If you only round to the tenths place, you'll get a slightly different answer. So make sure that you're following the directions for what to round to if they're present. And if you're not present, then be consistent to where you round to. On the filled in note guide, we rounded to the tenths place, so our answer will be slightly different. But again, since the directions didn't state what to round to, as long as you're consistent, you'll be okay. On tests and quizzes, it'll tell you exactly, or in a check for understanding, it'll tell you what to round to. So please pay attention to that. Okay, I have one more example, and then we'll begin. Here's our triangle angle. I'm going to make my quick table to organize. Angle C, little a, little b, little c. A is little a, across from C is little c, across from B is little b. So the three things I know is that I know length of little b is 21, I know length of little c is 13, and I know that angle B is 110. Note that this is a little bit different initial setup than before, because last time I knew something about each of these three side and angle pairs, and I kind of filled in using the missing angles. This time I only know one angle, and I don't know anything about either side A or angle A off the bat. But on a plus side, that does kind of focus in what we can find, which is I think the first thing we need to find is what angle C is. So according to our law of sines, we know that the sine of an angle divided by its opposite side is always the same. So I think right off the bat I know that sine of angle B over the side it's across from is equal to the sine of angle C over the side it's across from. I don't know what angle C is, but if I could get sine of angle C by itself, then I could use inverse trig functions. I could use sine inverse or arc sine to undo and find what angle C is. So I'm going to start just like I did. This is a proportion, so I'll cross multiply and get 21 times whatever the sine of angle C is equal to 13 times the sine of 110 degrees. I'm looking for C, so I need to get it by itself. So I need to undo this thing that's outside of this function. I need to divide by 21. So I know that the sine of whatever angle C is equal to 13 times the sine 110 degrees over 21. This is some decimal, and if you divide it in the calculator, you get some decimal out. Moreover, we need to figure out what angle C is, so we need to undo the sine. We need to get C out of this sine function. And if you recall from a previous lesson, to do that we'll use the inverse functions. So I'm going to use sine inverse, which looks like sine with this -1 that looks like an exponent. It's not really an exponent, but it's just the notation. So inverses and functions cancel, and we're left with just what was inside the function to begin with. In this case, that's angle C. So angle C is the inverse sine of this thing. You could figure out what this is, a decimal, and then do inverse sine of that decimal. On my calculator, I'm going to type it all in one big function here. So I'm going to find my trig. I'm going to use the inverse sine is on the outside. There's a fraction. And I'm going to do 13 times whatever the sine of 110 is on top, and on bottom is 21. And when I enter, boop, the inverse sine of this, whatever this decimal happens to be, is 35.5712. Or what this tells me is that angle C is about 35.57 degrees. Finding angle A is quick because I can just do 180. Now I can do 180 minus 110 minus this answer, 35.57, and calculate that angle A is 34.43. And now that I know angle A, I can use the law of sines with what's left over here to try to find what side A is, just as we did in the previous problem. So I know that sine of B over B is equal to sine of A over whatever A is. Cross multiply, A times sine of 110 equals 21 sines of 34.43. Divide by whatever the sine of 110 is. And little a is equal to this fraction. And again, I'll type that on my calculator. Fraction 21 times trig sine 34.43. And on bottom is trig sine of 110. And this tells me that A is 12.6354 or 12.64. And here is my triangle completely solved. Lastly, let's find the area. The area should be 1/2 side times the sine of an included angle. Since the angle that I calculated is 110, I'm going to use this as my angle. One of the sides is 13, and the other side is included between 110 is side A. Side A was 12.64. So 1/2 times side times side times the sine of the included angle is 77.2051, or about 77.21. Square units. Again, this area may be different may differ depending on how you round. So pay attention to what the directions say to round to, and if they don't, again, be consistent in how you round. In this case, I rounded to 2 decimal places, so I made sure my answer was 2 decimal places as well on my calculator.